Monday. All right, friends, let's take a look. Our fair game review for today. We are going to continue looking at measures of central tendency, calculating mean, median, and mode. What I'd like you to do is copy down these 7 numbers, okay? And what is the very first thing that we should be doing with all of that data? We should be putting it in order from least to greatest. All right, I think 14 is my smallest number, so 14, 15, 16, 18, 18, 20, 36. Oh, good. So what we're going to look at today is we're going to talk about something like this 36. Okay, does anybody notice that the 36, when you look at all of the data, whoa, that's gross, that the 36 looks very different. It's very much bigger than all of the other pieces of data. As a matter of fact, it's double 18. So here all these numbers are 14 to 20, and then all of a sudden you have this 36, okay? So 36 is actually called an outlier. Okay, outlier, a number far greater or smaller than the rest of the data, okay? And the reason why the outlier is important is because it can skew the data, okay? It can skew, which means it can make averages not look right. So for instance, if I were to calculate the mean of this set of data, remember we add it all up, okay? And then we divide by 7, you're gonna get 19 and 57 hundredths, okay? And I'm gonna let you know that. Now when I'm looking at that, that's way up here. Does 19 and a half really describe the most of my data? It kind of doesn't. And so when you have an outlier, you usually do not use the mean to describe the data. And that's why the median is so important, okay? So if you look at the median, okay, and we cross out the outside number, and the next outside number, and the next outside number, the number is 18, okay? Do you see how 18 is a better descriptor of the numbers that are in here, okay? So we're going to use the median, use when there is an outlier, okay? So you really look and use the median when there is an outlier. You use the mean when the data is spread out pretty nicely. Now the mode in this data, okay, is going to be 18. Now typically we'll use the mode when you're talking about categorical data. Well, that didn't work out so well, did it? Okay, we usually use the mode when we're talking about things that are non-numerical. Like if I were to give a survey about the favorite kind of ice cream, and I asked about chocolate, vanilla, or strawberry, if most of the people say that vanilla was their favorite, then that would be the number that I use, okay? So you use the mean when the number is evenly spread. You use the median when there's an outlier, okay, there's a number that's way too big or way too small, and you use the mode when it's non-numerical data, okay? All right, so let's take a look at our learning target for today. Okay, we will graph equations and inequalities on a number line. Okay, we will graph equations and inequalities on a number line. Okay, so here's this new word, inequality. So we're going to figure out what is an inequality. Okay, so first, let's start with graphing an equation. Okay, graphing an equation. So I want to give you the word equal because really that's something that's we have to understand, right? There means there has to be an equal sign. So it might be something that's like this, x equals 2. If I were going to graph that on a number line, first thing you need to do is have a ruler. Or if you don't have a ruler, you can find something straight, okay, like the side of a book. And we're going to draw a number line, okay? So we're going to draw a number line. And what I'm going to do is I'm just going to use my straight edge and draw a line. Now, in order for it to be a number line, it has to have arrows at the end. And I have to have the number 2 in it somewhere, right? So what I'm going to do is I'm going to make these equal intervals. And I'm going to put 2 somewhere. So I just need to make sure that on my number line is 2. And so we're going to go like, if this is 0, 1, 2, 3, this would be -1, -2, -3. Okay, yep, you can have negative numbers on your number line, okay? Now, if I wanted to graph x equals 2, we just come over here and we just put a solid dot on 2, okay? And we call this a closed dot. Closed dot, darkened dot, okay? And that's how you graph an equation, because it's equal. But sometimes we don't always talk about things that are only on 2, okay? So sometimes we have to do what's graphing inequalities, okay? Graphing inequalities. Things like greater than or less than. So let's start with greater than. So a number has to be greater than 3. So you have to be taller, okay, than 4 feet to ride a specific ride at the Six Flags or something like that, okay? And what that looks like is this. So we would have some variable, so y is greater than, and if I used a number, I could say something like 3. Y has to be greater than 3. Okay, it can't be 3, it has to be greater than 3. So how do we put that on a number line? Well, let's start by going ahead and I'm going to go down here just a little bit to give myself a little bit of space. Okay, going to start with my straight edge, making sure I have a line. Arrows at both ends. And I need to make sure that 3 is on my number line. So I'm just going to go through and do equal intervals. And I'm going to put 0 here, 1, 2, 3, 4, 5, and then this would be -1 and -2. Practice putting those negatives on your number lines, okay? All right, so y is greater than 3, but it can't equal 3. So it's hard to imagine, like, well, where do we put it? Do we put it at 4 then? Except for it could also be 3.5 or 3.1 or 3.01, right? So what we're going to do is we're going to put a dot around 3, okay, but leave it open because it can't equal 3. If it equals 3, it would be closed. It doesn't equal 3, so it's open. And then I need to say that it's everything that's bigger than 3. So I'm going to draw an arrow. Now what I always do is I draw a little line up and then I draw a line to the right. Some people just draw the line on the line, but sometimes it's hard to see where your line is. So I always draw this up and it kind of looks like a flag. Okay? And I'm saying that y can be any number bigger than 3. It can't be 3 because it's an open dot. Okay? And we call this one open dot. Open circle. Okay? All right, let's do the same thing for less than. And the same thing for less than. So we're going to say less than. Okay. And this time we're going to say something like m is less than, this is your less than sign, right? Is less than, let's do a negative number. How about -1? Okay, so what we're going to do is we are going to use our straight edge, whether we decide to use a ruler or something else that's straight. You can use the side of a book, right? You have to have the arrows on your line because that's going to say that it's a line that goes on and on and on, right? And then you're going to have equal intervals. Some people like to use a ruler. Well, I have a lot of intervals on this one. You don't have to. I usually say that you have to have at least 3 intervals. Between 3 and 5 is perfect. You'll see me do that a lot. Okay, so if this is 0, we've got 1, 2, 3, 4, 5, -1, -2, -3, -4. Wow, that worked out perfect. I didn't do that on purpose. All right, so remember, m is going to be anything less than -1, so to the left of -1, because all the numbers to the left are less, but it can't be -1. Okay, so I'm going to go to -1, and remember, a closed dot means it equals -1, but since it doesn't equal -1, we're going to do an open dot at -1. It says, okay, this is our special number. And then I'm going to draw a line up, and I'm going to draw a line going to the left. And notice that I also put an arrow at the end of this line because really this can go to infinity. Okay, it's any number less than -1. And again, we have an open dot. Okay. Now, what's really crazy is I'm going to introduce you to two new symbols. Okay. And here's the first new inequality. It's greater than, and actually it's greater than or equal to. Greater than or equal to. So what is that like? Well, it's like at least. Okay, so if I say, hey, you have to get at least 3 points on your assessment to be proficient, it means you can be a 3 or anything bigger, at least. Okay, and that one comes up quite a bit. So it's a good thing we're introducing that. So what I'm going to do is I'm going to draw another number line. Okay. Now, in this case, we're going to say that R is greater than or equal to. So I need a greater than symbol and an equal symbol. Okay? And what we're going to do is we're going to smash them together. And so the R is greater than or equal to. Look at that. Here's the greater than symbol, and there's half of an equal sign, right? Because it's greater than or equal to. And let's use the number 1. So R has to be at least 1. Okay, I'm going to do bigger intervals here because I don't need as many. There we go. And let's see. I'm going to say 0, 1, 2, -1, -2. You don't have to have 0 on your number line, by the way. Really, you just have to make sure that you have this number and at least 3 to 5 total intervals, okay? So I need to mash together a greater than and also an equal. When it was just greater than, it was an open dot. When it was equal to, it was a closed dot. So what we're going to do is we're going to mash those together again, and at 1, I'm going to put a closed dot because it can be equal to, but then I'm also going to draw the flag going to the right. And this one says if your variable comes first, and this one says that it has to be greater than, notice that this right here and my arrow are going the same way, but that's only because the variable comes first. So this one actually says R is greater than or equal to 1. It can be 1 and anything bigger. Okay, and again, because we have greater than or equal to, we have a closed dot. Okay, the last one that we're going to do, my friends, is less than or equal to. Okay, this would be like no more than. Okay, like you can have no more than 5 people in a sedan. You can have no more than 5 5 people in a sedan, because a sedan is a regular car. There's 2 seats in the front and there's 3 seats in the back. So you can have no more than 5 people. You could have 5 people, but you could also have 4, 3, 2, or 1 people, right? So let's go ahead and graph this. No more than. And we're going to say that n, and if it's no more than, less than or equal to, I'm going to mash the less than and the equal symbol together. And it's going to be no more than, let's go with -2. Why? I don't know, because we need to look at negatives. And I'm going to make my intervals a little bit bigger there. I've got 5. Now what I'm going to do is I'm going to start with -1, -2, -3, -4, -5. Because look, friends, you don't have to have 0 on your number line, but you have to have this number. Okay, and a total of 3 to 5 numbers. You could have more. Okay. Now, since n is less than or equal to, because it can be equal to, we got to put a closed dot because that means equal, but because it can also be any number less than that, my arrow has to point to the left because that's where all the numbers that are smaller than -2 live. Okay, and again, when I have less than or equal to, I have a closed dot. Okay. So, open dot, when your symbol is greater than, or your symbol is less than. Okay, closed dot, when your symbol is equal, greater than or equal, less than or equal. Okay, make sure that your arrow is pointing the right direction. Okay, if your arrow is pointing to the left, it means it's less than. This arrow is also pointing to the left. Okay, it means it's less than. If your arrow is pointing to the right, it is greater than. All right, friends, that is all for you today with graphing equations and inequalities. And let your teacher know if you have any questions. So now what we are going to do is we are going to practice writing inequalities. Okay, so like from a word problem. Okay, so for instance, and what we're going to do is really just practice like how do the words and symbols match. So let's say that I had something as x is greater than 7. So x is greater than 7. So we have x and we have 7, and here's this right here, is greater. When it says is greater and not just x greater than 7, because x greater than 7 is an addition problem, but x is greater, that word is means that now you have an inequality. So you have x and you have 7, and the inequality that goes in between them is greater. So x is greater than 7. Okay, and you can check your inequality by saying, okay, x is greater than 7. What's a number greater than 7? 10. Is 10 greater than 7? You betcha. Okay, let's take another one. M is less than 14. Okay, so the value of m is less than 14. So you have the numbers m and 14. We circle our numbers and then we box our key action words. And remember, it's is less than, because is tells us you have an inequality and not just a math statement. So you have m and you have 14. And if I were you, I'd always try to put the variable first. Okay, so m is less than 14. M is less than 14. So m is less than 14. That's how you would read it And this is how you read it. These things stay the same. Okay, let's try another one. How about R is at least greater than or equal to. Now, at least, greater than or equal to, those are the same things. I wanted to show you that, and then we'll take it apart, okay? At least, greater than or equal to 10, because those say the same thing. So R and 10, at least, is the same thing as greater than or equal to. It has to be at least 10 or greater than 10. And you can pick a number that's greater than or equal to 10 or at least 10. 11 is at least 10. 11 is greater than or equal to 10. Okay. How about P is no more than 7. So P and 7 are your numbers. And then you have is no more than. Is no more than. So it means it can be 7, but it can't be any more than 7, which means it can be less than 7. So this is actually less than or equal to. Okay? How about five is not more than x. 5 is not more than x. So you can write 5 and x because those are your numbers. And then we have is, but look at, this is very odd here, is not more than. Not more than x. Can it be x? Sure. But 5 has to be less than or equal to x. Now this is really interesting because I prefer to have the x on the variable on the left side. So I'm actually going to rewrite that. And basically what I'm going to do is I'm going to flip my entire inequality, because I can read this as 5 is less than or equal to x, or x is greater than or equal to 5. So I'm going to write it as x is greater than or equal to 5. And I'm going to prefer to write it with the variable first. Okay, it helps me when I graph my inequalities. So how about D is at most 35. Okay, D is at most 35. So I've got my numbers, D and 35 is at most. So I always ask myself, it's at most 35. Can it be 35? Sure. But it's at most 35. So can it be 36? No. But can it be 30? Sure. So that means D is less than or equal to 35. Okay. And let's see here. Let's do G is, what I haven't done yet, more than 17. Okay. G is more than 17. So G and 17 is more than, G is more than 17. Can it be 17? No, but it can be more than 17. Okay, here's our last one, okay? How about 23 is less than or equal to Q. So we have 23 and we have Q. And then we have is less than or equal to. So we have this whole thing here is less than or equal to. So if 23 is less than or equal to 2, or Q, I can go less than or equal to Q. But remember how I said it makes more sense if you put the variable first, especially when you're graphing? So we're going to rewrite this. It's 27 is less than or equal to Q, which means Q is greater than or equal to 27. Do you see how I just flipped that around? All right, friends, that is how you write inequalities algebraically.